All right. I recently took the Claude Certified Architect Foundations exam and I did not pass. I didn't fail by a lot, but I still failed. And so over the next week or so, I'm going to create videos for all of the sections that I struggled in. And in these videos, I'm basically going to talk through what I understood this topic to be now that I've delved into it a little bit more. My goal is to take the certification exam again in a couple of weeks, and I'm pretty sure I will pass because my initial score was 702 and I needed 720 to pass. I've got plenty of sections on this exam that are at 100%, but I've got 7 in particular that are at 0. So I'm definitely going to study the 7 that are at 0 and then also brush up on the ones that are like 67% or 50%, anything less than 100 essentially. So today's topic is configuring agentic loops to emit multiple tool calls within a single response turn, enabling parallel execution of independent subtasks and reducing total round-trip latency. So there are a couple of scenarios that immediately come to mind when you hear this particular topic. So the issue that you're trying to solve is that you're basically are asking Claude a question for which Claude requires answers from multiple tools. And when that happens, you really have 2 choices, and you as the architect get to decide how this is implemented. You could say, well, call each one of these tools sequentially and then combine all these results and send them back to Claude in one prompt. Or you can call all these tools in parallel, get the results, and when all of the results come back across all of these tools, send it all to Claude. The difference here is that if each tool takes 2 seconds to call and you have, let's say, 2 tools, so that's 4 seconds if you call them sequentially. If you call them in parallel, that's probably closer to 2 seconds. I don't think it's exactly 2 seconds because your computer or your servers, your environment, your system has to work a little bit harder to deliver that because it's doing 2 things at the same time. And there's always potential for blockage on either side of something, but it should be faster in parallel than it is sequentially. So based on that, I looked at a few potential scenarios that Claude is, or the Claude exam is trying to cover with this particular topic. And so the first one is optimization for latency. So it's exactly what I just said before. So calling tools sequentially always takes longer than if we can call them in parallel. And so rewriting our end of it for parallel execution is beneficial to Claude because we can supply multiple tools at the same time in order for it to work. The second thing is this broken loop. And here we are basically, and I'm kind of combining 2 and 3 together here because in my mind they're basically similar. One is a very specific error that you can get, and I believe it happens when you tell Claude that it's got a set of tools that it could use, but then by the time you get any kind of a response back to Claude, it doesn't use the same set of tools. That's my best understanding. Each tool has a unique identifier, and we are not using that correctly. And that, in my mind, is what API error is. Broken loop is something like where we potentially have Claude request multiple tool uses. We call the multiple tools, but we only look at the first response, which is partial and not the complete answer that Claude is looking for. So that is my best interpretation of that. The next one is multiple responses versus a single response. So in other words, if we ask if Claude comes back and says, hey, run tool A, B, and C, but we come back and we start delivering results one at a time, Claude doesn't know how to handle all that. It's expecting all of the answers to come back from one iteration as opposed to us returning stuff piecemeal. So in other words, it's looking to say, hey, run these 3 tools, and we're supposed to return one message with the results from A, B, and C. All right, next we have the fact that tools sometimes have to be sequential. And the easy example here is, you need to get a customer ID before you can look up customer orders. So you have to have a customer ID first. So that's the first call. And then the second call is to get the different orders for that customer. Now, tools must be identified, and this is the part of naming them. So I have some JSON that I will show in a minute, which has these pieces of information. Now, another thing that was interesting to me, I discovered that we can definitely turn parallelism off in Claude. So we can say, hey, Claude, everything that we're going to do is going to be sequential. And we do that using disable parallel tools use set to true when we submit the information to Claude, when we submit our requests to Claude. However, if parallel tool use is enabled, we cannot force Claude to actually do things in parallel. It has to come to that conclusion on its own. So we may have 4 or 5 tools, and Claude may say, well, just call this one. Or it can't really tell us to call them sequentially, but if it picked only one tool, we're only going to make one call, even though Claude realizes that it can call all these other tools as well. Since we're in control of calling the tools, I'm assuming that if we get response back from Claude that says call A, B, and C, that we can do that in parallel if our code is written that way. And I'll show you what I mean in a second. Finally, number 8 is, it's interesting to note that, and this is something that I struggled with just a little bit, but it's interesting to note that model decides what tools to call in a single turn, but we decide how those tools are executed. Claude does not know anything about the tools that we provide other than what we tell him. So it recommends that we call these tools, how they work, what's behind the scenes, how long things take. All of that is up to us and our application. And so let's look at a very simple example here. So most applications will have an agent loop. The demo that Claude and I put together doesn't actually have it, but in most cases is you're looking for a stop condition of end turn. And this is something we'll get to in a second. It's listed here on the bottom. So stop reason is end turn. And if it gets to that, that means whatever we were working on is satisfied and complete. So what happens in this agent loop? Well, the first thing is we submit a prompt that kind of looks like these 2 boxes right here. The first box is going to be the message that we want to submit to Claude. So in other words, this is our prompt. We're saying, what's the weather like in Las Vegas, and what's the price of the Microsoft stock? The second part is the description of the different tools that we made available to Claude to figure this out. We have one tool that is going to get the weather, and the second tool that's going to get the stock price. Now, the definitions here are pretty basic, right? We give it a sort of a function name. We say get weather, and we say we need to pass in a string, which is the city name, and something similar for the stock ticker. All right. So Claude grabs this information and reasons. So it's sitting there and thinking about what to do with this information that we just gave it. And it comes back with something like this. It says, all right, so I need you to go ahead and call these 2 tools. And it looks like at this point, Claude gives them unique identifiers. So we have a unique identifier, an ID for the get weather tool, and another unique ID for the stock price tool. And what we're expecting is that by the time we get the results, we want to return these identifiers back to Claude so it knows which tool provided this input. And if we get this wrong, then that's when we get that error in scenario number 3, that tool error that I showed you briefly. So we submit this, or rather Claude submits this down to our application. Our application reads the response from Claude. It reads it as an array. And so this is an important distinction too, especially if you're an architect. You could just take like maybe you're getting an array back. You could say, nope, I just want the first thing off of that array and I'm going to act on that and nothing else. In this case, we are saying we are going to loop through the whole array, figure out all the things that Claude wants from us, and then we're going to execute in parallel. So this is what our application is doing within our code. And so the conversation so far is this, right? We submitted this initial prompt to Claude. That's in green. Claude responded and said, run these 2 tools before I can give you the final answer. And then we ran our 2 tools in parallel and combined the results. And this is the result. So you can see again, we have the use of these unique identifiers, plus now the values for Microsoft and the weather in Las Vegas. And once we have that, we send this off to Claude as another response. And Claude comes back with the final version. So Claude basically says, hey, currently in Las Vegas, it's 104 degrees and sunny, and the Microsoft stock is trading at $512.34. It also provided that final stop reason, which is end turn. And so how do I get here? So I asked Claude to help me build a quick application to help me understand this. And it didn't do a perfect job, and it took me a few iterations to figure all this out. But basically, this top portion here is where we call or configure our Claude API key, so everything we need for Anthropic. Then we have some tool definitions here, and this is just basically an easy way to create the necessary JSON string. So tool def takes these parameters, puts them in a JSON string, and that's what it returns. And then finally, we have our initial prompt. And I will say this demo doesn't use a loop. So even though we're capturing the result and we're looking at, Claude say that end turn, we're done, we're not really doing anything with it. So there is no outer loop here that keeps repeating until something is completed. But here's our initial prompt. Here's where we send all of this to Claude with the list of tools that are available. And then, of course, all of this stuff comes back from Claude. And here is where we're going to execute on those results. We parse the JSON that Claude returned, and then we get our two applications in the switch statement. So we put them together into different tasks, and then we run all of them at the same time. And so when all complete, so this is the tasks array. So we want to run the weather tool and we want to run the stock ticker tool. The code above here just puts them all into this one array, if you will. And then we just execute them. And so then finally, we take the results that come back, we send those results back to Claude, and Claude comes back and gives us the final answer, if you will. So this application is very linear. It doesn't use that agent loop, but everything else works as you would expect. And then, of course, there's a bunch of simulations here. So we have like the fake weather tool, we have the fake stock tool, and we have some helpers. So this is the helper that makes the call to Claude. And then we have the other one that creates the tool definition right here. All right, so with that, if we just run that real quick, we get the results. And there's Claude's final answer. And so everything works. And today I learned a little bit more, especially about why sometimes things in parallel are better than sequentially. And this is something that I knew, but this is something that clearly on the exam I kept getting wrong. And so I think now that I understand some of these concepts a little bit better, the 2 or 3 questions that cover this will be a little bit easier for me. I now know what to look for. I know that I'm looking for scenarios where Claude either asks for multiple tools to be called and we've only used one, or that Claude is asking that, we use multiple tools and we're not returning all of the results. So there's a bunch of different conditions there that I guess I still need to read up on a little bit more, but they're definitely a little bit more clearer in my head.